In this video, we're going to prove that tangent of x is strictly bigger than x if we let x be in the interval 0 pi over 2. We can prove these results in many different ways. We can define a new function, let's call it g of x, to be tangent of x minus x, with x is in this interval. Okay, here we see that our function is continuous and differentiable on this interval, and therefore we can find the derivative. So g prime of x is 1 plus tangent squared of x minus 1, which is tangent squared of x, and this means that it's bigger than 0 on this interval. That means our function g of x is increasing. Okay, so if we let x in this interval, we see that g of x is bigger than g of 0. Okay, and g of x is tangent of x minus x, bigger than g of 0, which is 0, and therefore we have tangent of x bigger than x. So this is one way of proving this result. We can also graph it and see, but that's not enough. So here pi over 2 is a vertical asymptote. So this is pi over 2. So this is, let's say this is 1, 1, 1, okay? And the tangent is something like this, okay? And we see that the tangent is above x, and therefore it's the difference is bigger than 0. The only case where we have a problem is pi over 2, which is not included, and when we are at 0, we have 0. Okay. There is another way that we can use it to prove this result. We can use some trig identities. So if we use the unit circle, but in our case I'm gonna use just the upper half. So here this is the circle centered at 0, 0 and having radius 1. So this is 1, and this is the tangent when x is bigger than 0. Okay, so if for every angle in 0 pi over 2, so here x is gonna be here. Okay, I can find this area here. So this is the tangent of x. If this is x, this is the tangent. So the area of the blue rectangle or triangle is tangent of x times 1 over 2. So this is the area. Okay, so this is the blue area, and I know also that I can find this area here, which is a sector. Okay, the angle here is x and radius is 1. Therefore, the area of the sector is 1/2 x times 1 squared, which is the radius. That means it's x over 2. And clearly we see that the area in green is less than the area in blue. Okay, the area in blue is this one here. So that means it's less than tangent of x over 2, and this means that x is less than tangent of x, with x being in, let's say, 0 pi over 2. Okay, so this is one way or two ways to prove this result.